flux density. That's the very old friends of us. Flux density is V. And if B multiplied together with A, just like the populations of density of Jakartans multiplied by the area of Jakarta, then that's the total number of people in Jakarta, correct?
Yeah.
So if you have flux density, can be pictured like the density of the lines every square meter, the magnetic field lines every square meter, times the area, then basically, you call it?
Phi.
Phi. Or
Flux density.
flux. Flux, magnetic flux. Maybe in German it can be more real to you. The whole Fluss, der Fluss. It's just like the collections of all fields, magnetic fields. Understand?
Yeah.
Yes. Now, that's what we had yesterday. And then one word that also been introduced but not so deeply explained is if you have this flux and then you multiply it by the number of coils. Why? Because sometimes you only have one winding of a ring or one winding of a coil, but it can be much more different if you have more winding of a coil like this. Certainly the effect, have you learned it last time, especially the girls which have 500 windings and 1000 windings, then it will be different. So if you multiply with this one, then certainly it will have stronger effect, yes, on the induced EMF. And it has a name. Exactly on the very last sentence that our sister Kyra has read, there is the word for that, and multiplied by flux.
Flux linkage.
Flux linkage. Thank you.
Flux linkage.
Thank you. Can you write it in your paper or in your book? Yes. Flux linkage. Sometimes I associate that also with the link. So the more link you have between the lines and the electrons in the conductor, or between the lines, magnetic lines, with the conductor, the stronger it is. I heard someone singing here. Unfortunately, I don't have red jack here.
Sorry.
I think red jack here. Sorry, yeah.
Ow.
You know red jack?
No.
Small
It's coins.
coins. That's what we call red jack.
For beggars. Wait, it's not for beggars.
And even Warren Buffett gives all cents he has. You know Warren Buffett, right?
Yeah.
Enggak.
Yang Buffett.
Come on, Warren Buffett or Warren Buffett.
Enggak.
Don't know him.
Warung, tapi kok buffet?
Buffett or Buffett? I don't know how do you
I know
pronounce it. Buffett or
A
Buffett?
buffet, but not warung.
No, Warren Buffett.
Warren Buffett.
A person.
Oh, no, I don't know that. Who's that?
Billionaire.
One of the
Saya maksudnya.
one.
Bisa tuh.
You're only the chauffeur of him.
You have so much hair, bro.
Even Warren Buffett keeps the 1 cent in his pocket every day, every time, and he remembers all the cents he has. Amazing, right?
Genius.
Yes, it is.
Isn't it crazy that like 100.000 in coins in Germany?
Yeah.
5 euros, like in Germany, like ada 80.000 in your coins.
Oh, in his percent.
Iya.
In his wallet.
Yeah.
Yes.
Satu coin 5
Yeah.
euro.
Uh-huh.
Itu 80.000, like that's crazy. That's a lot. And a coin.
Currency.
I believe it,
Currency.
because he loves to collect
don't
all,
think
even
he-
the
I don't
small
think he does.
I don't know. I think it does. That's true.
He doesn't get.
So, the magnetic flux linkage, and then something interesting happened from this one, and it is so interesting to me since it's easier for me to remember it. And the flux is
NBA.
BA. That's right, MBA.
Nova.
That's
That's what we're
one.
in.
That's the only TV show that I watched when I was young, besides Dunia Berita, Dunia Dalam Berita. Yeah, the news. I didn't watch TV. I just watched this NBA 30 minutes in a week only. So yeah, that is the NBA. And then what is the unit then? Can you read that? The unit B is in the B in. Remember the magnetic flux density in T Tesla. Area can be anything, but the SI unit is meter squared, and NBAN doesn't have any unit, it's just a number of windings, so 1 or 2 or 3 or 100. NBA together will be now Weber. And exactly him who postulate the law of electromagnetic inductions. Even the law of electromagnetic inductions is named after Faraday, Michael Faraday's law, but actually he is it who formulate mathematically. So our electromagnetic inductions induced EMF will be and then change of flux. Remember, whenever you have a change of flux, that's a very important keyword. Electricity is generated if you have a flux change in time. So change of flux in time, which is sometimes in your level it's much easier to just write delta phi divided by delta time. But to all of you, to some of you maybe, who loves mathematics and can do the differentials, this will be also applicable.
Oh, I got a new pencil.
Okay, this can be applicable.
So cute.
The chalk makes me.
Shocks.
Alright, let's see the examples like I promised last time. One example is on page 284. On page 284. But before that, to make it sure that you really understand this electromagnetic inductions, I've searched a video. Oh yeah, by the way, you asked me about the channel. My channel's name is Clinic Ilmu. So for whoever of you is sick in Ilmu, you can come. Clinic Ilmu. If you want, you can find.
Let's stop him.
Huh?
Nothing.
To stop what?
Nothing. Clinic.
Dapat.
Got it.
Is my picture there?
Yes,
There's
I'm a
hardly
teacher
a lot
in
left
speaking
in my
college.
deck in
How many subscribers?
Yes, yes. Thank you.
83 subscribers.
Thank you.
Video yang kemarin berapa?
Yep.
There are a lot of video in German.
Who are these people though? Is it like your tempat les?
Yeah, one of them maybe. Or in student coding. Is it on?
Yeah, so this is just check sometime.
Who's
I think so.
this?
Yes. Okay. Now, while waiting, let's read on the next page. 284, please. Jasmine, can you read it?
Damn, I was talking here at the. Could you like show us the thing?
What is
284.
284.
Kara could read it first. I don't have the book yet, Papa.
Oh, you don't have the ebook?
No, I was stopping you.
Yeah. Can you share it?
280?
84.
Mhm.
Or perhaps as first
I have
Lily. You get it or not? You got it.
200 for the first.
The
Yeah.
first top one, the top sentence.
Alright. Note that magnetic flux density V in Teslas is the flux per unit area passing through an area at right angles to the area, i.e. normally. Therefore, 1 Tesla equals 1 Weber per square meter.
In general,
In
when
Do I continue?
yes, please.
In general, when the magnetic field is at angle,
Theta.
At angle theta, as you see it.
yeah.
So this flux density, and this is the area of the coil, for instance. So any conductor, anything, yes, can be rectangular, it can be square, yeah. Not only the circular coil. So whenever you have a flux like this, it's not effective. Effective where if you have it here, yes. So but here is not effective, causing the electricity to produce. More effectively, if the lines or the flux to be more exact, really cut and have the linkage with the coil in these perpendicular directions. Therefore, as you see here, you just take not all the lines you have here, but rather you have to first resolve it into these directions. You take the component of it, since this is the theta, so only this part is actually can effectively, not this one, but this part can effectively produce electricity. And this one mathematically has relation with this NBA. This is all the lines that you have is N times B times A. But you take the component, the x-axis component, which is then really perpendicular to the coil, and this part is NBA times sine or cosine. Since this is uncatheter, correct? Yeah, the adjacent, not the opposite of this angle. Then you multiply by cosine theta. Understand? And that is exactly in your book. You don't have to write it. Understand?
Yeah.
Okay. Therefore, M times phi is better described as BAN or NBA times cosine theta. Understand? Yeah? Alright. Now I hope it has been recognized already. I can. I want to show you, first I have to make sure that I have downloaded it. Yes, I have. I just need to make sure that I pick the right minute. Yes, here. This one, yeah? Alright. Turn on now. Einstein. Is it coming? Yes. In order to understand this, let's watch this again. It will be animated with the video. Are you ready, guys? Yes?
Wait. Yes, indeed.
So,
Zwischen Feldlinien durch die Fläche A an. Dafür gibt es folgende Möglichkeiten.
after this.
Spannung 0. In der zweiten Zeitphase tritt die obere Seite der Induktionsspule aus der Feldspule aus. Deshalb ändert sich nun die Anzahl der Magnetlinien durch die Induktionsspule kontinuierlich. Wir registrieren eine Induktionsspannung. In der zweiten Argumentation sehen wir, dass wir an den unteren waagrechten Leiterstücken immer noch eine Induktionsspannung registrieren, die aber jetzt nicht mehr durch die oberen waagrechten Leiterstücke kompensiert wird. Wir können alle diese Ergebnisse in einem allgemeinen Induktionsgesetz zusammenfassen. Für die Induktionsspannung in einer einzigen Windung einer Induktionsspule kommt es auf die Änderung der Anzahl der magnetischen Feldlinien durch die Fläche A an. Dafür gibt es folgende Möglichkeiten. Erstens, man zieht die Schleife aus dem Feld, dann verkleinert sich die effektive Spulenfläche pro Zeiteinheit. Oder man schwächt das Magnetfeld und ändert die Spulenfläche nicht. Oder drittens kann man auch daran denken, die Spulenfläche zu drehen. Auch das ändert die effektive Spulenfläche. Wir nehmen nun den Begriff magnetische Flussdichte für das B-Feld wörtlich. B ist demnach ein magnetischer Fluss, großes griechisches Phi, durch eine Fläche A. Umgeformt erhalten wir, der magnetische Fluss Phi ist das Produkt aus B-Stärke mal Fläche A. Die Fläche muss für diese Definition senkrecht zu den Magnetlinien orientiert sein. Der magnetische Fluss ist also ein Maß für die Anzahl der Feldlinien durch die Fläche A. Nun betrachten wir die Induktionsspannung UI. Wenn sich die effektive Fläche nicht ändert oder wenn sich das Magnetfeld nicht ändert, erhalten wir zwei ähnliche Formeln für UI. Selbstverständlich können sich auch A und B gleichzeitig ändern. Wir vermeiden dies aber, weil es zu mathematischen Problemen führen würde. Es ist zum Beispiel ein grober Fehler anzunehmen, dass die Änderung des Produktes gleich dem Produkt der Änderungen ist. Wir lassen für Rechnungen also immer die Fläche A oder das B-Feld konstant. Trotzdem ersetzen wir nun das Produkt aus B mal A durch den neuen Begriff magnetischer Fluss Phi und wir erhalten so das allgemeine Induktionsgesetz. UI ist gleich NI mal Delta Phi durch Delta T.
Okay.
Anhand dieser Formeln ergibt sich ein neuer Gesichtspunkt bei den Einheiten.
So that's the summary of all the inductions law. Okay? It can be B who's changed, or it can be A who is changed. It can be both. He doesn't want to do that because he thinks that it can be complicated for the audience, because the audience here comes from all different layers of students. It can be also from Realschule. Yes, and Realschule in Germany is not like Gymnasium who has mathematics competencies. Yeah, but for us it's still possible to do that, correct? Yes, because we understand after we know the differentials that it can be both and we know how to calculate it. Now we want to open the book. I open it from here. 283, let's see the examples number 1. Where do you find the examples then, by the way, about the inductions gazettes, inductions law? Where do you find it? From the half point downward. Can you see it? Yes?
Where?
If I have a book, now I can open it.
This one?
I think so.
The examples. The first one is number 1, the moving conductor. This is page 283. The first example you find here, the number 1 example, is actually here on the picture, this one. Okay, can you give a note? The first example you find in page 284, this example, the picture is not this one. This is not the picture. This picture is for example number 2.
I see it.
Yes, this book is not really good organized. So number 1, a moving conductor in a magnetic field is exactly that we did last time here. Understand? Can you give me can you give a comment in your paper perhaps? Yes. This is the example number 1. Okay, everyone?
Do you want
Yeah.
me to draw it?
It is like
You don't have to. You have the ebook right with you now?
Yeah.
Yes, you don't have to. Just to make sure that this example number 1 is from this picture. Okay? Alright. So what is the result then we have last time with this example number 1? You have a moving conductor, just one conductor like this, and then you understand that there is a change of area. Remember? This is the length times the zurückgelegte Weg, the distance traveled. And exactly the distance traveled is in German we call it überstrichene Area, in English we call it the swept
away.
out
Swept out.
area, swept by the überstrichene Area. Correct? Yes? If this is the magnetic field, the überstrichene Area, the swept out area. Yeah? Is it clear, everyone? Yeah? And this is L times delta S. And why the over delta T? Because the change of it, the change of area. Not the whole area, but the change of the area that has been done by it, that is überstrichen by this conductor, that causes the induced EMF. And this is epsilon, the same epsilon. And then you know that this delta S over delta T is equals to V. Not exactly. You still remember that delta S over delta T will be V if we think this V to be the average velocity. Correct? Meaning uniform motion. So our assumptions today in this number 1 example is constant speed, uniform motions. Understand? Yes. If you go to university, you study in engineering, don't think, oh, here the formula is BLV. No, BLV is just a simplified formula because we know that delta S over delta T is only a constant speed, uniform motions. Now, can you take that formula and write? So, if you have the first case like in this picture, then the induced EMF can be calculated easily using the product of B times the length of the conductor, the whole length or only the segment length? The segment length, be careful, which is in the magnetic field, right? Times the B. Understand it wrong? The second example is exactly that we want to do, and that leads us later on to this exercise. So what I explained now will be very useful for this exercise number 1. Okay? Now, this is the coil and this is the magnetic field, exactly like you have now here. Okay, what do you see in the rectangular coil? What is the length? What is the symbol of the length?
I.
No, the symbol of the length is not I, it's L.
Oh.
That's right. The symbol of the
Sorry.
width, W. And the number of the coil, the winding turns, N. Okay, now just a test.
Use the coil.
If the distance between this and this is 20 millimeter, just a test of your intuitions. If the distance between this side and this magnetic field is 20 millimeter, and the speed is 5 millimeter per second, how does it take? How long does it take for the coil to arrive in the magnetic field? I say again, the distance between this side of the coil with the magnetic field is 20 millimeter. And that's the distance between the one side of the coil and the magnetic field. And if the coil has 4 millimeter per second constant speed, how does it take?
5 seconds.
5 seconds. Yeah, it's not important actually for this example, but it's just to try grazing your intuitions on everything, including the speed. Okay? So this is the constant speed. Remember, pay attention. Now, we want to read this example first, and somebody read us for us. Jasmine, a rectangular coil moving into.
Wait, where are you at? Oh, a rectangular coil moving into a uniform magnetic field.
Stop. Just by reading, we know that. Just by reading, we know that this EMF is not caused by the change of flux density, right? Are you with me? Yeah, it's not changed by this, but only caused by this term. Why? Because the flux density, the magnetic field, is uniform. Uniform means always the same. Immediately, if you have the exam, immediately set it equals to 0. Why? Because there's no change of the flux density. The magnetic field doesn't change, meaning the change is 0. Understand? Are you with me, guys? Okay. You still confused? No? Are you okay? Okay. So only this one. Yeah? Remember, forget about that one. Only this one. So, Sister Jasmine, go on.
Consider a rectangular coil of n turns, length and width W, moving into a uniform magnetic field with flux density B at constant speed V, as shown in figure 8. Suppose the coil enters the field at time t equals
Yes.
to 0.
At time t equals to 0 means, here's the magnetic flux. Is it going into the page? Correct? Is it going into the page? Yes.
Yes.
Mm-hmm. So then here, is there any colors? Alright. Then here is our coil. Stand on the verge of this magnetic field. Understand, everyone? So this coil enters immediately as we start our experiment. Stopwatch starts. So the coil enters into it. Understand, yeah? Alright. Now, the time taken by the coil to enter the field completely. Now, easy. If we here to enters completely, then exactly this W,
Wait,
correct?
Pato,
Yes?
could I write down real quick? You said that we should cross off the second part and equal it to 0. And that's kalau apa? So I can
If-
write it down.
The magnetic field is constant. Yes, delta B, no. There is no change of B, delta B. You understand? Yeah. If my mass is always 90 kilogram, last month, this month, and next month, so is there any change of mass?
No.
No. Delta M equals to 0. But does it mean that there is no mass in me? No, there is my mass, 90 kilogram, but there is no change of mass in Mr. To. Are you get it?
Yeah.
You get it? Yes. Is it boring? You're almost sleeping. Are you okay?
Okay.
Did you have already coffee?
No.
No. Okay, you don't drink coffee? No, that's good. So you save a lot of money in Starbucks. That's good. You don't go to Starbucks, right?
Yeah.
So for this to be completely inside, once more. For this to be completely inside, how long does it take? You see, right? This length divided by
4 millimeters per second.
yes by 4 millimeter per second if it's the velocity. But if the velocity is v, then w divided by v. Is it clear? That's the reason why I asked you to raise your instinct calculative mental maths. Understand, yeah? Alright. Are you okay, brother? You just drink, I think, the coughing weird, yeah? During this time, continue. Santa Jasmine.
Oh, sorry. During this time, the flux linkage N, what is it called? P?
And V. Yes.
Increases steadily from 0 to V and LW.
B and A, right?
V and
NBA.
A.
Increases from
Oh.
0 to NBA, correct?
Right.
NBA? Is it NBA? Are you sure this is NBA?
B and A.
LW, is it an A? L times W, is it the A?
Yes.
Yes. Increases from 0 to NBA, correct?
Yeah.
NBLW, NB the LW is just NBA.
Okay.
Okay? Increases from 0 to NBA.
Therefore, the
Yeah.
induced EMF equals the change of flux linkage per second.
Let me help you now. Do it correctly. It's just a little too fast for some people. So now I just use this one. Epsilon is just N and B constant. Correct? N and B constant. And then you have delta A divided by delta T. Alright, yeah? Now, you know the T is W divided by phi. So now I just consider the time as it enters and the time as it's fully inside. I just consider this time frame. If I just consider the time frame, which is from entering and until it's fully inside, then and B, the A at the last moment, is the A as it completely inside is L times W, correct? Yes?
Yeah.
And the A as it hasn't entered the magnetic field is 0. Are you with me, guys? Yeah? It's just one example of
Minus
the
0.
changes of area. It doesn't have to be that situations. If you want, you can also say, okay, I want to consider something as Serto. I just consider until it's entered only the half of it. Can it? Can it? If you want to. But these examples only says, as it enters, T equals to 0. No flexion, no area inside the magnetic field. And until it's completely drained, completely inside. But it's just his will. It's just completely deliberately done by him, but not necessarily only that situations. Understand? If I want to choose something else, I may do it. Got it, everyone? Yeah?
Wait, what's the minus 0?
Because the minus 0, because he observed the situations before the coil is coming, as it's just about to start. And just about to start means it doesn't have any area inside the magnetic field. Are you with me? Do you guys understand now? Yeah? Just about is here, not yet in. So now just about 0 area. Okay? But then now enters until it's completely inside. And then he stopped the stopwatch and said, okay, that's the end of our stay. That's the end of our Zustand. Zustand ended. And Zustand. Yes, sir.
So the 0 is the area of
The area of the coil,
coil inside.
not the area of the coil. So this A is basically the area of the coil inside.
Inside there.
Yes, inside.
Okay.
If there is no area of the coil inside,
Then 0.
0.
Okay.
And that's exactly at the very first, right?
Mm.
That's the Anfang Zustand,
Yes.
the first state. And the end state, end Zustand, is as it's completely here. Got it, yeah? And the question is not necessarily only until here. I may change the questions in the Klausur. First state, Anfang Zustand, and end Zustand can be half of the area. Can I ask that in the Klausur? Yes, I may ask that. Or maybe maybe in one of my student my colleague has even asked from here everyone, until here, and then here completely, until it goes away again. The whole process is asked by him. And he requires even the differential. I don't require you to do the differential, don't worry.
Amen.
Yeah. I don't require the-
I thought, is that a minus? Like, why is it double
Yes,
minus?
that's the minus. That's the minus 0. And now, where's the type? Delta T. Understand? Delta T. So the induced EMF, in this case, whereby the first state T equals to 0, the area is 0, and the end state T equals to T ended, end state, inside, area is LW, meaning this means that the whole coil is now for the first time inside the magnetic field, completely drilled, completely inside it. All right, everyone? Yes. Are you okay, Jasmine?
Yeah.
Right. So you get that formula. Mhm. And I want to use these questions. I want to use the questions on page 285 to be our numerical examples. Okay? To be our numerical examples. Do I hear some force word, F word?
What?
I heard some F word here. Lorentz force? Did you
Yeah,
say
yeah,
Lorentz
yeah.
force?
Yeah, force.
Oh, okay.
That's force.
Ready, huh? I'm going to use this.
Yes.
No way. It's not the end of our lesson, huh?
It is.
It's a break.
It's a break, not by that.
It's the end of our lesson.
Yes, here we go. Drink cafe lah.
I ordered
Hey,
cafe.
you're so cute. You're straight, huh?
Yeah, I'm not okay.
Okay, I'm not here, right?
Are you Vincent? Are you bisexual or are you straight?
You're sexually
I don't
straight.
know.
Did you hear that? You're sexually straight.
It's questionable, you know. As a person who understood him.
Ignore her. Ignore her. Just do a break with me, okay? Ignore her. You're straight. I believe it. Don't worry. I
No,
believe
he's
it.
gay.
Huh?
He's gay. We'll discuss this when you're back. Please discuss his gayness.
I would be gay if I identify as a woman.
So you like men?
He likes men. He likes.
He just admitted it.
What? Oh.
See, so you are gay.
No, I'm not.
Okay, fine.
This is
Half.
gonna go on YouTube.
Okay, hide. Hide.
Hey, you guys bullying him lah. Stop. Kasihan lah.
Hide.
Be merciful.
No, I know him well, Pato.
Yeah, but he said he's not.
See, now he's thinking about it. Because he knows I'm right. Ah.
Yeah.
Jesus, can you cut this?
Is it clear so far, Mindy, Kyla? Or not clear? What do you mean? That's terrifying. I don't understand.
The way like can tell your mood, like hello, like yum. Okay, guess what? Guess what I think. Yeah. Yeah, I got it right. Go on. Pigeon. No, it's alright. Yeah.
You don't really want to.
Yeah. You got it right. See? It tells your mood.
Nice discovery.
What? Yeah. He needs pepper, but here. Hast du auch damit aufgenommen?
Ja,
Okay. You ever had dann wieder geschlossen.
Ja, genau. Ja, ist aber passiert.
So
Ist ja gut so.
Ja.
I can only feel the sounding.
For real, do you see the post? The one of their wallpaper?
Yeah, yeah. I just saw it.
I can't believe they did it for dating.
I still date him.
He looks like he's 10.
His stepfather.
Yeah.
That's kind of ugly building. Why is it from broken like that?
Which one?
That black wall.
Where? Where?
Yeah, it's the only building you can see.
Oh, ew. Is it because it's black? He caught that on camera.
It's like black at the top and then
It's just straight. What is it? What kind of building? Hello, everybody. Welcome
Welcome to
this
my YouTube video.
Welcome to our podcast. This is about us now. This is my penthouse. I actually can't. I don't know what else to do if I'm not rich in the future. Like, what else do I do? Okay, I will kill myself when I'm not rich. Would you kill yourself if you're not rich? Okay, we both kill ourselves if we're not rich.
In like 40,
Okay, let's give it like, no, but I can be rich by like 50. Like,
yeah, that's what I said.
Jesus, we're like 40 and 30 to 25 years.
That's so weird. We're almost 20.
Stabil ist das nicht.
Schon wieder bei dir jetzt.
We're closer to 20 than we are 10.
Herr Neukirch und ich haben was am Laufen. Also, ich bin gay. Herr Neukirch.
Okay, did you hear that?
Oh ja, das ist alles Schiss auf ihr.
Okay.
Ist doch
Das
auch
ist